Stop for a second and imagine this. You're racing across the universe at the speed of light. But here's the twist. No matter how fast you go, there's a cosmic speed limit you can never break. What if I told you that understanding this number, light speed, is not just about memorizing digits, but unlocking a secret that governs everything you see, everything you touch, and even the invisible particles dancing through space?
Hi, I'm Richard Feynman, and today we're going on a journey through the wonders of physics, where curiosity is the compass and imagination is the engine. You're about to see why physics isn't just equations on paper. It's a story about the universe, a story that even the tiniest particle can tell.
I wasn't always a physics genius. I started just like you, asking questions that most people thought were too silly to answer. But those questions led me to the edge of what we know about reality.
I won the Nobel Prize, sure, but that's not why you should listen to me. What I want to show you is how to see physics differently. Quantum mechanics, particles, light speed, they're all like characters in a story, and the universe is a plot so fascinating you can't put it down.
Today, I'm going to reveal things about light speed that most textbooks skip over, secrets that will make you rethink everything you thought you knew about space, time, and reality itself. Now, you might have heard the number before, 299,792,458 meters per second. Pretty precise, isn't it? But numbers like this are just the surface. Behind them is a universe of behavior that's far stranger than your wildest science fiction. Why is it that nothing, not even the fastest spaceship you can imagine, can surpass this speed? Why do particles, photons, even the tiniest quanta of energy all obey this cosmic speed limit? Most people stop at the formula, but I want you to dig deeper. I want you to think like a physicist, the way I did when I was scribbling notes in my tiny office, connecting dots that nobody else even noticed existed. You see, I've always believed that physics should be fun, not intimidating. That's why I taught quantum mechanics with puzzle stories and even little sketches, what later became known as Feynman diagrams. These diagrams aren't just lines and arrows. They're a way to see particles interacting, a way to make the invisible visible. They reveal the dance of matter and energy in a language anyone with curiosity can follow. Today, I'll use that same approach to unravel the mysteries of light speed. By the end of this video, you'll not only know what light speed is, but you'll also understand why it matters and why it frames the very structure of our reality. But here's something most people don't know. While I was lecturing and writing, I always kept one question in the back of my mind. What if the universe is stranger than we can imagine? What if reality doesn't behave according to the rules we expect? Quantum mechanics forced me to confront this every day. I discovered that particles can be waves, energy can appear out of nowhere, and observation itself changes the world. It's a strange, breathtaking perspective, and it all connects to light speed. Because when we explore why light is the fastest thing in the universe, we uncover rules that make the bizarre behavior of quantum mechanics not just possible, but inevitable. So here's what you'll learn in this video. We'll trace the journey of light, from photons racing across galaxies to the smallest particle interactions you can barely imagine.
We'll explore why light speed is the ultimate speed limit, why it shapes the cosmos, and why even in the strangest corners of quantum physics it never wavers.
I'll share stories from my life that most people have never heard, how I wrestled with these ideas late at night, how I drew the first Feynman diagrams on napkins in a cafe, and how the simplest questions often lead to the deepest truths. These are insights that don't just expand your mind, they change the way you see the universe. By the time we're done, you'll understand why curiosity is the most powerful tool a human being can have. You'll see that physics isn't just for geniuses. It's for anyone willing to ask questions, willing to look at the world with awe, and willing to follow the clues wherever they lead. And trust me, when you see light speed through the lens of quantum mechanics, you won't just know a number, you'll feel the rhythm of the cosmos, the pulse of reality itself. Now, I have to warn you, some of the things you'll discover in this video are counterintuitive. They might seem impossible, even paradoxical. Particles that are waves, energy that behaves like matter, photons that race across the universe like cosmic messengers, all of it might twist your mind at first. But that's the beauty of physics. If it doesn't surprise you, you're not looking closely enough. Stick with me, because the payoff at the end is profound, a new way of seeing the universe, and a new respect for how curiosity and imagination can illuminate even the darkest corners of knowledge. Before we dive in, I want you to do one thing. Imagine a world where light speed wasn't the limit, where particles could move faster than the cosmos allows, where time might bend in ways we can't predict. It's exhilarating, isn't it? But the universe doesn't allow it. And that's precisely what makes understanding light speed so fascinating. We'll uncover why this rule exists, how it governs everything from distant stars to your own existence, and why breaking it isn't just difficult, it's impossible according to the laws that shape reality. So if you're ready to see the universe through my eyes, to explore the physics behind the speed of light, to question everything you thought you knew about space and time, you're in the right place. This is Feynman Flux, the channel where curiosity leads and where we journey together into the heart of physics. Subscribe now, because every week we unlock more mysteries, reveal more wonders, and remind ourselves why science is the greatest adventure of all.
Join me, and let's start this curiosity-driven journey. Light speed is just the beginning. What we discover along the way might just change the way you see reality forever.
Light moves faster than anything else in the universe. But do you really know why? Most people think they do. They throw around the number 299,792,458 meters per second like it's just a piece of trivia. But that number isn't just a fact. It's a key to understanding the fabric of reality itself. And today, I'm going to take you behind the scenes, the way I've always done, to show you how the universe really works. I'm Richard Feynman, and if you stick with me, you'll see physics in a way that flips your brain, that makes the invisible rules of the cosmos not only understandable, but thrilling.
I want to start at the beginning because beginnings tell us a lot about the person, about curiosity, about the way a mind opens to wonder. I was born in New York in 1918. From the very start, I was that kid who asked why over and over again, and nobody seemed to mind. I'd tinker with radios, pull apart clocks, and even at 5 or 6 years old, I was convinced that the world had answers if only you looked closely enough. My father encouraged it, saying, "Don't just memorize things, Richard, understand them." That advice stuck with me my whole life. MIT came next, then Princeton, then a stint working on the Manhattan Project. I was part of building the atom bomb, yes, but my real thrill came from thinking about the world itself, about why things move the way they do, and how we can see patterns in the chaos of particles and energy. What really defined me wasn't the Nobel Prize or the research or even the discoveries. It was curiosity. The simple, persistent curiosity that drove me to ask strange questions. Simple questions. Questions that seemed almost foolish, like, what would it look like if I chased a beam of light? Or how do particles know how to interact? Those questions turned out to be the key to understanding quantum mechanics, light speed, and the rules that shape reality. And here's the thing, I solve problems not by memorizing formulas, but by asking questions in a way anyone could understand. That approach is now called the Feynman technique. You take a concept, explain it in the simplest terms possible, and through that process, you truly grasp it. It's not about being a genius, it's about curiosity. And it works for everything, physics, math, life itself.
Now, let's dive into some of the most fascinating physics insights I've uncovered. Light speed isn't just a fast number. It's a rule book for the universe. At everyday speeds, we think we understand motion. Throw a ball, run across a field, drive a car. But the universe doesn't play by everyday rules. When you get close to light speed, particles behave differently, they gain mass, time stretches, and energy transforms in ways that seem impossible at first glance. And here's a little secret. Even these bizarre phenomena can be made comprehensible with a little imagination, a few sketches, and we have Feynman diagrams. Those diagrams aren't just lines and arrows. They're a visual language that lets you see how particles interact, collide, and transform. It's like watching the invisible threads of the universe weaving themselves in real time.
And here's an example that will bend your mind. Imagine chasing a beam of light. You sprint as fast as you can, heart pounding, arms pumping, eyes fixed on that dazzling photon. You might think, if I move fast enough, I'll catch it. But no matter how fast you run, the light still moves away from you at the same speed. Not slower, not faster. The same 299,792,458 meters per second. That's not magic, that's physics. That's the universe speaking a rule so fundamental that every particle, every star, every bit of energy obeys it without exception. And that realization, it changes the way you think about everything, from the tiny quarks inside an atom to the farthest galaxies racing away from us.
Here's a little story you might not know. As a kid, I used to build small electric circuits just to see how they would behave. I wasn't satisfied with reading about currents or resistance. I had to see them, feel them, watch them,
Once I spent an entire afternoon measuring the deflection of a tiny magnet, and I realized something astonishing. Even in simple, everyday experiments, nature has rules that are precise and absolute. Later, when I encountered light speed in my studies, I saw it in the same way, like a thread woven into every corner of reality. The laws aren't just numbers on a page, they're principles that dictate how the universe dances.
Feynman diagrams came later, but they were born from the same principle, seeing the invisible. With those diagrams, I could map out interactions that no one could see with their eyes. Particles splitting, recombining, exchanging energy. And through those sketches, I could make predictions, explain anomalies, and even understand why light speed remains constant no matter what. These tools let us grasp concepts that, without imagination, are nearly impossible to understand. You don't need a supercomputer or a massive lab. You just need curiosity and the willingness to follow where the questions lead. Think about this for a moment. Light speed shapes everything you experience. It limits how fast information can travel. It frames the rhythms of time and space. It tells particles how to behave. Without it, there'd be no clocks, no relativity, no quantum weirdness. And yet, it's invisible, intangible, fleeting, something we only truly grasp by observing, calculating, and imagining. That's what makes it so mind-blowing, and why it's the perfect example of how physics combines curiosity, experimentation, and pure thought. I've always believed that learning is about play as much as it is about rigor.
When I was at MIT, I used to challenge friends to explain a complicated concept in the simplest way possible, sometimes using a drum, sometimes a cardboard box, sometimes just words. That playful curiosity led to the insight that underpins the Feynman technique. The path to true understanding is through simplification, explanation, and imagination. And if you apply that to light speed, to relativity, to the quantum world, the results are astonishing. Suddenly, what seems impossible becomes intuitive.
Here's another little-known fact. During my time on the Manhattan Project, I wasn't just crunching numbers. I spent time thinking about the principles underlying the physics we were using. I was fascinated by the idea that even in the most destructive applications, the universe obeyed precise, beautiful rules. That curiosity, mixing all with rigorous questioning, is what drove me to discover patterns others overlooked. It's the same curiosity that allows anyone to see light speed, not as a number, but as a fundamental property of reality, a law that shapes everything from the smallest particle to the grandest galaxy. So here's what I want you to do as we move forward. Think about how light speed affects every aspect of your life. Imagine particles zipping through space, photons racing across the cosmos, time stretching and contracting, the universe itself obeying a set of invisible rules. Ask yourself questions no one has asked before. That's where true understanding begins. And when you do, you'll see that the laws of physics are not distant, abstract concepts. They are alive, interactive, and endlessly fascinating. Now, before we go deeper, I want you to ponder this. How does light speed shape everything we see and feel? How does it define reality, govern particles, and set the rhythm of time itself? Think about it. Let your curiosity wander. And when you've got a wild guess, share it in the comments. That's what physics is all about. Curiosity, questioning, and the joy of discovery. Nature's imagination is far greater than ours. Think about that for a second. The universe is more inventive than anything we can dream up. And if you want to understand light speed, the fastest thing in existence, you have to see it the way nature sees it, not just as a number, but as a rule, a rhythm, a law that shapes every corner of reality. I'm Richard Feynman, and today we're going to explore light speed through the eyes of curiosity and imagination, where quantum physics, tiny particles, and invisible forces come together in a cosmic ballet you can actually learn to see. I want to start with me just for a moment, because knowing where I came from helps you see why I think the way I do. I was born in New York in 1918. Even as a kid, I couldn't stop asking questions. Why does a magnet stick to the fridge? Why do radios make sounds when you twist the dial? My father encouraged me to explore, to tinker, to puzzle things out. Later, I went to MIT, then Princeton, and worked on the Manhattan Project. Yes, that project, the atom bomb. But the thrill for me wasn't just building weapons. It was uncovering the secrets of the atom, seeing the invisible mechanisms that run the universe. I won the Nobel Prize for quantum electrodynamics, sure, but the real prize was curiosity itself, making curiosity a superpower. That's what changed everything. Now let's talk about light speed. Why can't anything go faster than it? That's a question that has fascinated physicists for over a century. The answer isn't simple, but it's beautiful. Light speed isn't just a speed, it's the backbone of the universe. Space, time, matter, energy, they all obey this rule. If you try to break it, reality itself pushes back. Imagine you're chasing a beam of light. You run as fast as you can. You think you'll catch it, and yet light keeps moving away at the same speed. No tricks, no exceptions. That's the universe speaking, and that's what makes physics so astonishing. Most people think light speed is just about photons, but it's far bigger than that. Light speed is baked into the fabric of quantum mechanics. It governs how particles interact, how forces transmit, and how the tiniest bits of energy move. And here's where the magic comes in. I found a way to see these interactions using something called Feynman diagrams. Imagine particles interacting like dancers on an invisible stage. Electrons, photons, quarks, they swirl, collide, exchange energy. Feynman diagrams are a map of that dance. They let you see the invisible, predict outcomes, and understand why light behaves the way it does even before you measure it. Suddenly, the universe isn't abstract. It's visible, tangible, almost playful. Let me give you an example. In quantum electrodynamics, a photon can interact with an electron in 1,000 ways. Most of these interactions are tiny, almost impossible to detect. But using Feynman diagrams, I could track every path, every interaction, and calculate the probabilities. It's like peeking behind the curtain of reality and seeing all the moving parts of a cosmic machine. And when you understand these interactions, you see why light speed is constant, why it's the ultimate limit, and why the universe is far more orderly and imaginative than we ever thought. Here's something most people don't know. I love puzzles more than textbooks. When I was a kid, I'd take apart radios and clocks just to see how they work. Later in graduate school, I applied the same curiosity to particles and fields. I realized that physics isn't about memorizing equations. It's about asking questions in the right way, simple, strange questions, questions that make you think. What if? That mindset led to discoveries that most people call genius, but I call curiosity. And it's exactly how we uncover the mysteries of light, of quantum mechanics, of everything around us. Now, here's a fascinating insight. I once said, the pleasure of finding things out is unmatched, and it is. That thrill, the rush, when an invisible rule suddenly clicks into view, that's what physics is all about. Light speed is just one example. When you study it through quantum mechanics and Feynman diagrams, you start to see that the universe is full of secrets waiting to be uncovered. Time dilation, particle interactions, the bending of light near massive objects, it all flows from the same principles. And it's not just theoretical. These ideas explain how GPS satellites work, how particle accelerators smash atoms, and how light from distant stars reaches your eyes in precise ways. Let's pause for a moment and imagine something mind-bending. You're watching an electron and a photon interact. You can't see them directly, but you can map their paths with a diagram. You see possibilities branching, probabilities shimmering. Some paths cancel each other out, some reinforce, and the final result is exactly what experiments show. No magic, no imagination required, just the rules of nature revealed through careful thinking and a little creative visualization. That's the genius behind Feynman diagrams. And that's why light speed isn't just fast, it's a cosmic law embedded in every particle, every interaction, every event in the universe. Even on the Manhattan Project, amidst all the pressure, I found ways to explore these ideas. While others focused on calculations for bombs, I kept thinking about the underlying principles. How do particles behave at extreme energies? How does light transmit force? Why does nature obey simple rules that lead to such complex behavior? Those questions didn't just make me a physicist. They kept me engaged, alive, and deeply curious. That same curiosity is what allows anyone, yes, anyone, to appreciate the beauty of light speed and quantum physics.
Here's another story you probably haven't heard. I once tried to teach a class on quantum electrodynamics using only everyday objects, coins, strings, and even paper napkins. My students were baffled at first, but then they started seeing patterns. Electrons interacting with photons, probabilities, and conservation laws all became visual, tangible, even playful. That's the way I see physics, not as an obstacle, but as a puzzle to explore, a story to tell, a universe to uncover, and light speed is the perfect doorway into that story.
So, as you think about all this, consider the questions I would ask if I were here with you. How does light speed define time? How does it shape every interaction in the quantum world? How does it set the stage for the cosmic dance of particles? These aren't just idle questions. They're the keys to seeing the universe as it truly is. And here's the exciting part. You don't need a lab, a supercomputer, or a Nobel Prize to start asking them. All you need is curiosity, imagination, and the courage to look closely. Finally, I want you to imagine asking me one question about light. Anything. How does it travel? Why does it obey a limit? What does it mean for the universe? Pause, think about it, and comment below. Let's see who dares to think like a physicist, who dares to explore the invisible rules that govern reality. That's the essence of learning, the essence of discovery, and the essence of seeing light speed not as a number, but as a living, breathing part of the universe itself. So what did we learn today? Richard Feynman showed us that physics isn't just equations on a page. It's curiosity, play, and the joy of discovering how the universe works. From light speed to quantum mechanics, he taught us to see the world with wonder, to ask questions, and to never settle for just memorizing facts. Feynman reminded us that science is a way to think, to explore, and to enjoy the thrill of understanding.
If you enjoyed this dive into Feynman's mind, make sure to like this video, leave a comment with your favorite Feynman insight, and subscribe to Feynman Flux for more science inspiration. Click on another video next. There's a whole universe waiting to be discovered, and we'll explore it together. Keep asking questions, keep learning, and remember, the pleasure of finding things out is all yours.